Now that you have mastered the definition of a derivative using that limit definition and you feel really confident about it, we're going to learn some rules that are going to essentially replace it for most of your practical use. So these are what we call the shortcut rules or the basic differentiation rules. This is what you really need to have down as far as knowing formulas. So the very first one is what we call the constant rule. The derivative of a constant function is always 0. So anytime you're taking the derivative of a real number, there's no x's or anything like that, the derivative with respect to x of c is going to be 0. So we're going to look at a proof of this one because this one is really short, simple to prove. It's a very pretty proof. So in this case, f of x, we're going to let be c, the function c. So the derivative with respect to x of c is going to be the limit as h approaches 0. Remember that's f of x plus h minus f of x divided by h, which is the limit as h approaches 0 of, now let's think about this. If f of x equals c and you go to plug in x plus h, you don't add h to the end of that. F of x plus h is just c. F of x is also c, so we get the limit as h approaches 0 of c minus c over h, which is 0 over h, which is the limit as h approaches 0 of 0. And the limit of a constant is always that constant. So the answer here is 0. So that is the end of our proof. Really simple. So the derivative of a constant is always going to be 0. So if you wanted to find the derivative with respect to x of y equals 7 and y equals negative 35, the derivative with respect to x of 7 is going to be 0. The derivative with respect to x of negative 35 is going to also be 0. The next rule that will become your best friend over the next couple of months is the power rule. The power rule is how to take the derivative of x raised to any power. So if n is a rational number, then the function f of x equals x to the nth is differentiable, and the derivative with respect to x of x to the n is n times x to the n minus 1. So we've got the derivative with respect to x of x to the n. And one way that people like to think about this is kind of a looping thing. So we're going to bring that n out front, and then we're going to subtract 1 from the power. So that's where the n x to the n minus 1 comes from. In order for f to be differentiable at x equals 0, n must be a number such that x to the n minus 1 is defined on an interval containing 0. So we're going to find the following derivatives using theorem 2.3 and by using the limit definition. The limit definition is not going to be as fun as you had hoped, so this will show you really quickly why these are nice formulas to know. So if I want to find the derivative with respect to x of x to the 5th, using the formula, my n is 5. So this is going to be 5x to the 5 minus 1, or 5x to the 4th, and you're done. That's all there is to it. Really straight, simple. That's theorem 2.3. Now, in order to do this using the limit definition, you need a little bit more information. So you may remember from one of your classes, the binomial theorem. We covered this, I know, in Math 112. This says that if I take a plus b and raise it to the 5th power, in this case I'm going to use x plus h, this expands to be x to the 5th plus 5x to the 4th h plus 10x cubed h squared plus 10x squared h cubed plus 5x h to the 4th plus h to the 5th. So just keep that in mind because we're going to use that in a second. So using the limit definition, remember this was theorem 2.3. Using the limit definition, the derivative with respect to x of x to the 5th would have to be the limit as h approaches 0 of x plus h to the 5th minus x to the 5th over h. So you can see where this comes in handy. This is the limit as h approaches 0 of this whole long thing here, x to the 5th plus 5x to the 4th h plus 10x cubed h squared plus 10x squared h cubed plus 5x h to the 4th plus h to the 5th all minus x to the fifth, all divided by h. My x to the fifths cancel. And I have the limit as h approaches 0 of 5x to the fourth h plus 10 x cubed h squared. I'm just going to go ahead and write all this out for you. So it looks like that, and then when you factor an h out of that numerator, notice every single term now has an h. You get this. Notice our h's cancel. I'm just going to go ahead and plug in from this point. So that would be 5x to the fourth plus 10x cubed times 0 plus 10x squared times 0 squared plus 5x times 0 cubed plus 0 to the fourth, which would equal 5x to the fourth, which is what we found earlier. So not a surprise. So these shortcuts can really make your life a lot simpler. Keep in mind you will have to do one limit definition, but if you're not told specifically to use the limit definition of a derivative, you can use the shortcuts if it doesn't specify. Okay, so let's look at some examples that use the power rule. Some of these will obviously use the power rule. Some of them you might not recognize it at first or how to do it. So we've got the derivative with respect to x of x to the fourth. So this is going to be 4 times x to the 4 minus 1 power, or 4x cubed. Very simple. So that is the answer there. Now let's take a look at this one. We've got dy over dx. We're trying to find dy over dx when y equals the square root of x. And remember, all these notations mean the same thing. So another way that we could write the square root of x is as x to the 1/2 power. So this is a power rule in disguise. So we've already seen in section 2.1 how to do the limit definition of this. We're just going to use the shortcut. So this is dy over dx is going to be, using the power rule, 1/2 times x to the 1/2 minus 1, which is 1/2 times x to the negative 1/2. And if this is understood to be our denominator line or our fraction line here, whenever you have a negative power, you can bring it down to the bottom. So that would be 1/2 times 1 over x to the 1/2, or 1 over 2 square root of x. So notice the answer is exactly the same thing that we got in the previous section doing it the long way. And when you see something like this one, f prime of x, when f of x equals 1 over x cubed, we're going to use that trick again, except in this case we're going to go up and make that negative. So f prime of x is going to be negative 3x to the negative 3 minus 1, which is negative 3x to the negative 4. And again, I'm going to bring this down and change the sign, so I get negative 3 over x to the fourth. And then finally, the derivative with respect to x of x. You could think of this as the derivative with respect to x of x to the first power. So if you brought down a 1, that would be 1 times x to the 1 minus 1, or 1 times x to the 0. And anything to the 0 power is just 1. So this one might be worth learning and in just using. The derivative with respect to x of x is always going to be 1. That would probably be an important form for you to know. We can use these shortcuts when we're trying to find the slope of a graph, or when we're trying to find the equation of a tangent line as well. So remember, the slope of the graph is the derivative evaluated at that point. So I'm going to find f prime of x first, and this is going to be 3x to the 3 minus 1, or 3x squared. So then at x equals negative 1, m would be f prime of negative 1, which is 3 times negative 1 squared, or 3. At x equals 2, m would be f prime of 2, which is 3 times 2 squared, or 12. So really straightforward. If you needed to find the equation of a line tangent to a graph at a given point, you can do that as well. So in this case, the slope would be f prime of x, which would be 5x to the fourth. And at this case, when x equals negative 1, m would be f prime of negative 1, or 5 times negative 1 to the fourth, which is 5. Now, you need a slope and a point. If you know the x value, at x equals -1, y is just going to be f evaluated at that. So if you ever just need the point, always go back to the original function. That would be -1 to the 5th or -1. So our point is going to be -1, -1. So this is our slope. Our point P would be -1, -1. So I'm going to use that same equation as before. Y minus y1 equals m times x minus x1. So that'll be y minus -1 equals 5 times x minus -1. Or y plus 1 equals 5 times x plus 1. Or y plus 1 equals 5x plus 5. And if I subtract the 1, I get y equals 5x plus 4. So this is the equation. Always be very careful when you're working these problems and make sure to read the directions, because the directions can be very subtly different and you actually need to do something completely different. So be very careful when you read the directions on these problems.